Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the A-level mathematics subject of partial fractions. So early in our mathematical career we learned to subtract fractions. A third minus a quarter, we put them over a common denominator. 4/12 minus 3/12, that's 1/12. We can also subtract fractions algebraically, so algebraic fractions, so 1 over x plus 1 minus 1 over x plus 2, put them over a common denominator of x plus 1 times x plus 2. That gives us x plus 2 over x plus 1 times x plus 2 minus x plus 1 over x plus 1 times x plus 2, which is 1 over x plus 1 times x plus 2. And actually this is a generalization of the result for simple fractions that we just did. So if we put in x as 3, this is a quarter minus a fifth, and if we put in x as 2, this is a third minus a quarter, which is 1 over 3 times 4, which is 1 over 12. So actually this, as is often the case, algebra is a generalization of arithmetic, and so for different values of x, this can give us various different results for normal fractions. Anyway, the point is we can subtract algebraic fractions using a similar technique than the one that we learned for normal fractions earlier on in our mathematical careers. We can also go the other way. So if someone gave us 1 over x plus 1 times x plus 2, we can decompose that into two simpler fractions. So a over x plus 1 plus b over x plus 2, I've got to work out what a and b are, and then we multiply the top and bottom by x plus 2 and then the top and bottom by x plus 1. So now all of these fractions have got the same denominator, x plus 1, x plus 2. So if we equate the numerators, we've got an equation, or kind of two equations. So if we equate the numerators, we can see that on the left-hand side, we've got no x's, and on the right-hand side, we've got a plus b x's, so a plus b have to be 0. If we equate the constants, on the left, we've got 1, and on the right, we've got 2a plus b. So 2a plus b is 1. So a equals minus b, because a plus b is 0. And then when we put in b for minus a here, we get a equals 1. A equals 1. And if a equals 1, then b equals minus 1. So that means that 1 over x plus 1 x plus 2 is 1 over x plus 1 minus 1 over x plus 2, because basically here a equals 1 and b equals minus 1. So we've gone the other way. We've started with 1 over x plus 1 x plus 2, and we've decomposed it down into two things which are called partial fractions. Now, why would we want to do this? Well, it's very, very helpful in integration. So if we're integrating 1 over x plus 1 x plus 2, we can write that as the integral of 1 over x plus 1 minus the integral of 1 over x plus 2. We know, don't worry if you haven't done integration yet, but this just shows why it's important. So the integral of 1 over x plus 1 is log x plus 1. The integral of 1 over x plus 2 is log x plus 2. So we get log x plus 1 minus log x plus 2 as the integral. And using the laws of logarithms, we can say that's log x plus 1 over x plus 2. Let's try some more. This is a more complicated one. So 7x squared plus 10x plus 1 over x plus 2 squared times x minus 1. So we're going to decompose that into three partial fractions, a over x plus 2, b over x plus 2 squared, and c over x minus 1. So when we've got a repeated factor like this, x plus 2, we have to put in, we can't put in x plus 2 twice. So we put in x plus 2, and then we put in x plus 2 squared. And by the way, this can also be integrated quite easily, so this is helpful. And then we put in the other factor, x minus 1. So that's why we've got a squared term here, because this was a repeated factor. So what we're going to do is we're going to look at this, we're going to use common denominators again, so we're going to create a common denominator all the way through, which is x plus 2 squared times x minus 1. And then these are the numerators that we get out. So for instance, on this term, to get to x plus 2 squared x minus 1 on the bottom, we had to multiply top and bottom by x plus 2 times x minus 1. If we expand all of that stuff out, then what we get to is, because what we've done here is we've basically said numerators are equal. So 7x squared plus 10x plus 1 equals a times x plus 2x minus 1 plus bx minus 1 plus cx plus 2 squared. We then expand out these brackets like this and make them equal. And then basically, firstly, we've got to show that we've got to equalize the coefficients of x squared. So we've got a plus cx squared on the left, we've got 7x squared on the right, a plus c is 7. Then we make equal the coefficients of x, so we've got ax here, we've got bx there, we've got 4cx here. So a plus b plus 4c equals 10. Then we've got to equalize the constants, so minus 2a minus b plus 4c equals 1. So what we have here is three simultaneous equations in three variables. If we, I touched the wheel there, which made it all unhappy. Okay. What we're going to do is we're going to add this equation to this equation. So what we get then is we get a minus 2a, which is minus a, b minus b, which is 0, so the b's go, and then you've got 4c plus 4c, which is 8c. So minus a plus 8c equals 11. And then what that tells us is when we add minus a plus 8c equals 11 to a plus c equals 7, this gives us the a's cancel. We get 9c equals 11 plus 7 is 18. 9c equals 18. That means c equals 2 if we divide both sides by 9. c equals 2. If c equals 2 here, then a must be 5, because 5 plus 2 equals 7. If you like, take 2 from both sides. a equals 5. So now we've got c equals 2 and a equals 5. So what we can do is we can really put it in anywhere, but let's put it in here. So we've got a equals 5. We've got c equals 2, so that's 5 plus 8 is 13. So b must be minus 3 to make this lot equal to 10. So c equals 2, a equals 5, b equals minus 3, which is the final solution to this thing. So actually, when we go back to this, we get 5 here, minus 3 over x plus 2 squared, plus 2c. I think I remember that correctly. There we go. A equals 5, b equals minus 3, c equals 2. Let's try one more. This is reasonably common. Difference of two squares. So we're going to resolve 8 over x squared minus 4 into two fractions, simpler fractions. A over x minus 2 plus b over x plus 2. So to get these into a common denominator, we're going to multiply the top and bottom of this by x plus 2. Because x squared minus 4 is x minus 2 times x plus 2. So we multiply top and bottom here by x plus 2. Top and bottom here by x minus 2. So it's 8. The left-hand side numerator is a times x plus 2 plus b times x minus 2. We're going to equate the coefficients again. So a plus b is 0 because there are no x's on the left. So a plus b is 0. We're going to equate the constant coefficients. 2a minus 2b equals 8. And then we divide through by 2 here. A minus b equals 4. So 2a equals 4, because basically we add these two together. So 2a is 4. The b's cancel. A is 2. And if a is 2, b must be minus 2, because a plus b is 0. B is minus 2. And that's it, party people. I hope you like the video. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas. And most of all, I hope you enjoy your mathematics.